Hello, everyone. Thanks for joining us on this morning on this predictive gateway presentation. My name is Felipe, and I will be your host. Today, contents will be gateway description, gateway networking, and gateway security and troubleshooting. Let's start with the gateway description. What is a gateway? A gateway is an appliance that is installed on-site that provides connectivity between predictive serverless cloud with on-site devices. This allows us to monitor all the devices that are present on the site from different locations. This also allows for zero-touch configuration to access on-site devices for monitoring and control from the NOC center. There is no need to open ports for the port forwarding. There is no need to create VPN or site-to-site tunnels from the office to the site. It is a common practice to create site-to-site tunnels between the main office or the branch office to the site that we want to monitor. And it is quite often to do port forwarding in order to access those devices in case that a VPN site-to-site tunnel is not available. Why does Predictive produce the gateway appliances? In the last few years, we have seen a rise of the attacks against IoT devices. It only takes one unpatched or badly configured IoT device to be exposed into our internal network or be compromised by a hacker or a malicious user, and then the whole network is broke down to its knees in terms of security. We implement what is called a site security, meaning that the security is applied to the boundary of the site. But inside the site or inside the network, it relies unprotected. We don't enforce that much of security and authentication as with external access. Because of this, one device that is unpatched can be used as a target by hackers to access our network. Sadly, in the market, the responsibility of patching relies on the manufacturer. The manufacturer needs to be up to date with latest security trendings and provide those updates to their devices as long as they are in their support cycle. If the device that you have installed is already end of life, you will not receive more updates pertaining to security. That means that in case that a new vulnerability is found tomorrow, then that device will be exposed. And if it has port forwarding or an open port to the internet, then malicious users can use that to attack your network. We use the gateway in order to prevent that. The gateway disables the needs or prevents the needs to open ports on your internal site network. By only accessing our cloud network range, the gateway appliance can access the devices on site and then create a secure tunnel between the gateway and the serverless cloud that we have on predictive premises. The number of malware samples for IoT devices has been doubled each year according to Kaspersky's lab collection. Another reason that why we produce gateways is because of interoperability. Interoperability means that each device will talk a specific set of protocol or language that only those that can speak that language can understand. We abstract that from the user and we manage that using microservices. The microservice is the function inside the gateway that provides translation from each data type or data protocol into a common language that is presented inside the predictive platform. This allows us to present the same data regardless of the device or what protocol it uses into the predictive dashboard. We can consume any type of protocol by creating a new microservice for that specific protocol. We can use JSON as on the top. We can use XML as on the bottom. We can use SNMP. We can use HTTP, among other protocols. Another feature that the gateway provides is data persistency. Data persistency means that the data is stored locally and then it is sent to the internet. We often found vendors that provide monitoring solutions to the devices that they have on site. They say if you have 5, 10, or 20 devices of the same brand, you can purchase their brand monitoring solution, and then you can monitor the devices from that brand. But what happens with the other devices that you have? What happens with your switches, with your UPS, with any other IoT devices that you have on site? Those should remain unmonitored because there's not enough devices on site to afford the complete monitoring solution of that other vendor. In that case, it will be very expensive to buy that monitoring solution from each vendor. With the gateway, what we do is that we aggregate all of that into a local database, and then we send that to our centralized dashboard. Since it is centralized, you don't need to purchase different monitoring solutions from each vendor that you have on site. And the best of all is that since there is a local database on the gateway, the data is retained on the gateway temporarily until we can get online again and send that. Most of other vendors out there do not provide local database for their devices since their monitoring solution and data collecting features remains on the cloud. In the case of the gateway appliance, it remains local to the site. And when we become online, we can send that out. Let's talk about now gateway hardware details. Here is a picture of one of our Gateway X model. This Gateway X model does provide an antenna with an embedded modem to provide 4G connection in case that the on-site connection is unstable or not available at the moment. We can see the vent on the left. We can see also the DC power outlet. The DC power adapter is included in the box. We can also see the Ethernet port that goes to the switch and provides internet connection. And on this model, the Gateway X, this is the RF antenna port that provides a cellular signal to the device. Now let's talk about some recommendations for this. Always connect the AC adapter into 110 volts outlet. You have an AC adapter going to the outlet that comes out as a DC supply to the gateway appliance. Always connect the RF antenna on the back on the selected model. This is required in order to gain signal to the embedded modem. And make sure you have cellular signal on the site. This is very important. We have had sites where we send the device, the technicians install it, and then they found out they don't have a strong signal on site and the connection keeps flapping or it's not getting connected at all because they were relying on that modem. So it is very important that you verify that on the site or on the room that you're going to install the appliance, you have at least 3 out of 5 bars of cellular signal from the carrier that you intend to use. In case that you want to use the embedded modem, we support multi-carriers. So any carrier with at least 3 out of 5 bars will do it. On the network side, the recommendations is always test the Ethernet cable before connecting. This is very important. We have had situations where the Ethernet cable is bad and a second site visit is required to change that. So use one Ethernet cable tester before connecting it. Connect the gateway into the same switch where the device to be monitored is connected. We use Ethernet as the way to communicate with the device. So it's very important that the gateway and the device are connected to the same switch. And also test internet access on site. The gateway appliance requires internet in order to connect to the predictive cloud. This is a requisite that we have on the device itself. Always test with a laptop or a computer, connect to the switch, and verify that turn off Wi-Fi, and then verify that you do have internet via the switch. When you are mounting the gateway into the rack, if there is a rack available on the site, use a 19-inch rack mounting. The gateway does provide 4 racking holes to put the screws inside the rack. The installation instructions of the gateway are the following. You may want to take a picture of this if you want. Open the box carefully to expose the gateway. Take out the gateway, the LAN Ethernet cable, antenna and power adapter. Mount the gateway in the 19-inch rack. Connect the power adapter to the power outlet and to the gateway. Connect the LAN cable to the switch and the other end to the gateway. Make sure this cable is properly tested. Screw in the antenna on the back, and you're done. Now, let's take a look at the gateway networking and how this all comes together in regards to what connects to where. This is a sample diagram of how the gateway connects to the other devices on the site. In this case, we are monitoring the DAS, which is a distributed antenna system. This equipment is frequently used on buildings that require to extend the signal across several floors or spaces that the normal carrier signal cannot get in. We also are going to monitor the UPS, which is an uninterruptible power supply. We are going to monitor the modem, and we are going to monitor the switch. As you can see in the picture, each of these devices go into a specific port in the switch. Since they all share the same network, the gateway can fetch the data from each of these and then get online using the modem outside connection to the internet. Another way that we can get online is using the 4G cellular modem. This is only on the model that applies. We have the gateway that can use either the on-site modem to get to the internet or 4G cellular modem that is embedded on the gateway in order to access the predictive serverless analytics engine. All the data is crunched and sent to this engine, and then it is processed to have alerts and monitoring. Let's talk about regarding bandwidth. One of the features that we do support on the gateway appliance is what is called a native interface tunnel. This tunnel allows the device to be monitored to also be accessed by the technician or the user using the predictive dashboard. You don't need to have a port forward in the site in order to do this. Okay, we create what is called a tunnel inside the gateway that connects back to another tunnel on the predictive cloud, and then they can talk to each other, and then they can present the web page that the appliance sees on the site to the user browser in the dashboard. This is a feature that we recently added to our feature list, and is very used because you don't need to log in independently via port forward. This also allows you, because we had concerns about the security, this eliminates the need to open ports on the site because now you can log into the device. Let's see that you have a value that you want to correlate with what predictive is showing. What you can do is that you can go over here, you can log in using your username and password and the group, and then you can verify that value yourself. This tunnel requires 1 megabit per second in order to function, and this is only available when you have LAN connections. If you want to have multiple tunnels, there's a maximum of 1 tunnel using the modem and up to 10 tunnels using the LAN connection. When you have more than 1 tunnel, each tunnel will require 1 megabits per second. The normal bandwidth requirements without the tunnel is only 56 kilobits per second, which is very low bandwidth these days. So any even if you have a 2G connection or a 56K modem, it can work with that, only for data fetching. The firewall recommendations for the gateway is that you need to be online. This is important. And the firewall needs to provide internet access on port 443 for this to work. No inbound ports needs to be open. Only outbound is required. The gateway LAN IP needs to be whitelisted in order to access the internet if you have a strict inbound, outbound firewall policies. We use a pool of IPs in the internet that can change frequently in order for us to scale over the time. So we cannot get fixed by a single IP. So it is important that the gateway does have access to the internet on any IP, always on port 443. No need to open ports on the site. This is not a requirement since the gateway can provide monitoring and native tunnel interfaces. And also, it is configured by default to have DHCP. That means that the gateway can get any dynamic address on itself when it goes to the site. It's important that if you're going to have a DHCP reservation, put that on the monitor devices, because if the monitor devices IP changes over time, then we lose track of it. It is important that to have that on the firewall. If there is no DHCP available on the site, the IP needs to be communicated to Predictive before shipping the device, so we can install the static IP before it's going out. This is important in order to reduce the time to deploy the appliance to the site, since it has happened that we ship the gateway and when it gets on site, it cannot get online via the LAN IP, only using the internal modem on specific models. And then we need to use the internal modem and consume data in order to update the IP, and this reduce the deployment. This extends the deployment time of the appliance. So that is an important part. You need to inform that in advance. Let's talk about now about gateway security and troubleshooting. One of the reasons that why we produce gateway, as we have spoken before, is that malware attacks are doubling each year since 2013. This poses a very big risk to anyone that is deploying devices on different networks and required to access them outside. Maybe you have an intelligent door lock, or you have an intelligent IP camera, and you want to access that outside. It will pose a risk, since if you can access that from the outside, then the bad users can do as well. Since this is happening, we have developed many features, security features inside the gateway. We do provide end-to-end encryption using AES 128 cipher between our appliance and our cloud. We use certificate-based authentication for tunnels. That means it has a digital signature on every tunnel. We use certificate-based authentication for a messaging queue. That means that we provide digital signature as well on every message that is coming out of the site, so it cannot be replayed, mangled or tangled in transit, or presented any other information. We protect the credentials leaking compared to port forward in HTTP device. This is important. One of the most commonly overlooked things about port forward is that if you have a non-encrypted web server in your device, let's say you have a web page in that device that you want to monitor, you need to provide credentials when you need to log in. But if that is not in HTTPS or secure HTTP, that means your credentials are leaked as soon as you type them on your browser and on the way to the device. That means that your ISP knows your credentials. Any intermediate exchange internet companies between your ISP and the destination IP can see that, and the ISP of the site can see that as well. If you are in a public space sharing Wi-Fi and your Wi-Fi is not well protected, anyone just besides you can see that information as well, because it is broadcasted when you're using Wi-Fi. It is broadcasted to all directions. And if someone has a Wi-Fi monitor around and can crack your Wi-Fi packet, they can see that. This is why it's important that you always have secure tunnels and security in place. We ensure the confidentiality on HTTP devices. This is because we encrypt all the data. And we do not expose devices to wide open internet attacks because we do not require open ports. This is an illustration of how this works. We have a DAS device, and we have an on-site modem, and then we have a network operations center user that is accessing the device using port forward. They access the modem public IP, and they use a specific port that was open on this modem in order to access the DAS. Since this is an unencrypted tunnel, this information is leaked in route to the NOC user. From the NOC user to the modem and to the DAS, it is leaked in that direction as well. This is what is called a legacy port forward. When you use the native tunneling, let's say that you want to access the same DAS using the predictive dashboard, and you select the option of native interface, the communication is encrypted end-to-end. Since the device already can only support unencrypted protocol, then we still need to stick to it. But the unencryption happens inside the site and is between the gateway and the device. From gateway onwards, it's encrypted, as we can see on the bottom arrow. It goes encrypted to the on-site modem and to the internet and up to the NOC user that has the keys to decrypt that information. This is important. As you can see on the dotted line, this is the site. All the unencrypted part remains inside the site. So we don't expose that outside of the site or over the internet. Anyone that is on the site can access this information as well, but you will first need to require permission to access that. Common problems and resolutions. These are the frequent problems that we have seen so far in the field whenever they are installing the device or they are trying to set it up for the first time. Gateway showing as disconnected in the dashboard. You need to confirm that it is plugged in and the Ethernet cable is laid on the switch port. In some models of the gateways appliances, there's no power light on the front. So in order for you to know if it is actually turned on and it is connected to the switch, go to the switch and look at the port where the gateway is connected. You should see that the port should have an orange or green light and may or may not be blinking. This on difference, if the gateway is not power on, there will be no lights on that port. So that part is important. Gateway did not fail over to 4G modem. We have had scenarios where the gateway is installed, it's working, and a few days later, there is an internet outage on the site, and the gateway did not connect after that. We have found after investigating the issue that the antenna was not installed on the back plate of the gateway. So the modem could not get any signal at all from any carrier. Ensure that the antenna is screwed into the backplate and that there is a strong signal on site, at least 3 out of 5 bars. The gateway cannot reach the DAS or any monitor device that you may want to monitor. You need to place the gateway into the same switch or the same network as the DAS device. This is important because sometimes you have a large network and you have the DAS located in a different switch than where the gateway is connected. Or you have like a firewall between the gateway and the DAS, and then we cannot access the DAS anymore because the firewall segregates a new network inside of it. It's important that you place the gateway into the same switch as the device to be monitored, since this is required to have that. In case that you have some advanced network requirements that you cannot do that, please inform that in advance, and then we can run your scenario with our engineers and they can provide a recommendation. Thank you. If you have any questions, please put that on the chat box.